I'm going to tell you something right now that most videos on this topic save for the very end. Everything we're about to cover, every planet, every star, every galaxy ever photographed, makes up less than 5% of what actually exists. The other 95% is invisible. We can't see it, touch it, or detect it with any instrument ever built. We only know it's there because of what it does to the 5% we can see. That's where this video ends up. Everything between here and that reveal. That's the journey. And trust me, by the time we get there, that 5% number is going to hit very differently than it does right now. Before we go any further, please like the video and subscribe to the channel. It helps us grow and reach more curious minds like yourself. Now let's start with something you can actually picture. Earth is about 12,700 kilometers across. If you printed that distance on a ruler, 1 centimeter per 1,000 kilometers, Earth fits on your index finger. The sun's diameter on that same ruler stretches 11 meters. The length of a school bus. That's the size difference between the planet you live on and the star it orbits. You on the ruler are dust. Now the distance between them. Light. The fastest thing in the universe, fast enough to circle the entire Earth 7 times in 1 second, takes 8 minutes and 20 seconds to travel from the sun to us. Which means when you look at the sun, you're not seeing it as it is right now. You're seeing it as it was 8 minutes ago. There's a delay between reality and what you can observe. Remember that. It gets much worse. Neptune, our outermost planet, is 30 times farther from the sun than we are. Light takes 4 hours to reach it. Voyager 1, our fastest spacecraft launched in 1977, has been flying for nearly 50 years. It's still inside the outer edges of our solar system. The solar system is not a place you pass through. It's a place you spend a lifetime crossing and still don't finish. Now here's where the scale stops being something your brain can handle comfortably. The nearest star, just the nearest one, is 4.24 light years away. That's roughly 40 trillion kilometers. If you drove there at highway speed without stopping, the trip would take 48 million years. Here's how to feel that number. The first dinosaurs appeared on Earth about 230 million years ago. If one of them had started that drive, it would be 4% of the way there right now. Still driving. Still 96% to go, and that's the closest star. The nearest neighbor in a galaxy containing up to 400 billion of them. Most stars are separated by distances that make this one look like a short commute. I've been thinking about space for years, and I still can't genuinely feel the distance to Proxima Centauri. I can say the words. But feel it? No. I think that's actually worth admitting because the numbers we're about to deal with only get harder. Our galaxies, the Milky Way, contains somewhere between 100 and 400 billion stars. The range is that large because counting them is like trying to count every tree in the Amazon while standing in the middle of it. At night, the galaxy is about 100,000 light years across. Our sun sits roughly 26,000 light years from the center. Not at the edge, not in the middle, just out there in a quiet stretch between spiral arms. Here's the analogy I want you to use. Imagine shrinking the entire Milky Way until it fits inside the continental United States. Coast to coast, border to border. At that scale, our entire solar system, the sun, all 8 planets, everything Voyager has ever passed, is smaller than a single grain of sand. Somewhere around Kansas, that is our address. 1 grain of sand in a continent. The sun orbits the center of that galaxy at 828,000 kilometers per hour. Fast enough to cross the US in about 15 seconds. And even at that speed, 1 full orbit takes 225 million years. The last time the sun sat at this exact point in its journey, Pangaea was still intact. There were no flowers, no birds, no mammals, nothing that would recognize us as related to it. That was one lap. The sun has completed about 20 of them. At the center of the galaxy sits a black hole, Sagittarius, a star, weighing 4 million times the mass of our sun. We can track stars orbiting it that are moving at 3% the speed of light, close enough that the warping of space-time Einstein worked out on paper in 1915 becomes measurably, visibly real. A theory written by hand in a notebook, confirmed by watching invisible things move. That never stops being remarkable. Now we leave the Milky Way. Our galaxy belongs to a cluster of about 50 galaxies called the Local Group. The largest member, Andromeda, contains roughly 1 trillion stars and sits 2.5 million light-years away. You can see it tonight with the naked eye, a faint smudge in the northeastern sky, easy to miss. And when you find it, when that light enters your eye, it left that galaxy before our species existed. Homo sapiens weren't yet a thing when that light began its journey to you. It has been traveling longer than we have been human. Andromeda is heading toward us. In about 4 billion years, the two galaxies will collide and merge. The night sky will look completely different, but very few individual stars will actually collide. The distances between them are too vast. Two galaxies passing through each other is mostly a gravitational event, like two ghosts walking through the same space, each feeling the pull without making contact. Our local group sits inside something called Laniakea, a supercluster of 100,000 galaxies stretching 520 million light-years across. That's the structure we actually live inside, not the Milky Way, not the local group. Laniakea, and everything inside it is being pulled towards something called the Great Attractor. A gravitational anomaly with the mass of tens of thousands of galaxies dragging millions of galaxies, including ours, toward the same point in space at roughly 2 million kilometers per hour. We cannot see it. Our own galaxy's dust and stars are blocking the view completely. We only know it exists because we can measure the motion of everything around it, and all of it is being pulled toward the same location. Something enormous is sitting behind the curtain of the Milky Way. We can feel it pulling us. We can't look at it directly. I find that genuinely unsettling. Now, the observable universe, the sphere of space from which light has had time to reach us, is about 93 billion light-years across. It contains approximately 2 trillion galaxies. If you shrunk the entire observable universe down to the size of Earth, the Milky Way galaxy, 100,000 light-years wide, up to 400 billion stars, would be smaller than a single human cell, not visible to the naked eye, barely detectable under a microscope. 2 trillion of those, packed into something the size of this planet. Sit with that for a second. And here's where we arrive at what I told you at the beginning. All of that, every galaxy in that sphere, every star, every planet, every atom in every gas cloud floating between galaxies, is ordinary matter. Protons, neutrons, electrons. The stuff the periodic table describes, the stuff you're made of. Less than 5% of the universe. About 27% is something called dark matter. It has mass, real measurable gravitational mass. But it doesn't interact with light in any way. Doesn't emit it, absorb it, or reflect it. Every telescope ever built sees nothing. We know it's there because of what it does to the things we can see. Galaxies rotate faster than they should based on their visible mass alone. The math simply doesn't work without something extra. Dark matter forms invisible halos around galaxies. The Milky Way extends roughly twice as far as our visible stars and contains several times more mass than everything we can actually observe. Right now, as you're watching this, billions of dark matter particles are passing through your body every second. Through the floor, through the earth, without interacting at all. Scientists have built detectors deep underground, shielded from every interference they can think of, and waited. Years of waiting. So far, nothing definitive. We know it's everywhere. We cannot touch it. The remaining 68% is dark energy. This is the one that should genuinely bother you. In 1998, two separate teams of astronomers were studying distant supernovae, exploding stars bright enough to see across billions of light years. They were measuring how much gravity was slowing the expansion of the universe. What they found instead, the expansion isn't slowing down, it's accelerating. The universe is expanding faster today than yesterday, faster yesterday than the day before. Something is pushing space itself apart, and the more space there is, the stronger that push gets. Both teams assumed they'd made an error. The results held up. They won the Nobel Prize. Dark energy, whatever it is, makes up 68% of everything that exists. The most honest thing physicists can say about it is that empty space seems to contain energy. The universe expands. More space appears. More energy fills it, which drives more expansion, a process that accelerates forever. And here's what that means long term. Every galaxy outside our local group is being carried away from us by this expansion. Right now, we can see 2 trillion galaxies. But as the universe continues accelerating, galaxies will eventually be moving away from us faster than their light can travel toward us. They'll disappear. One by one, they'll cross a threshold beyond which we can never see them again. Future civilizations, if any exist billions of years from now, will look up at a sky containing only the few dozen galaxies gravitationally bound to us. No evidence of the 2 trillion beyond, no detectable cosmic microwave background, the afterglow of the Big Bang that we can still see today. No way to know the universe was ever larger than what they can see. They'll have no way to reconstruct the full story. We can, right now, but only because we're alive during a specific window in cosmic time when the evidence is still visible. That window is closing. Here's what I keep coming back to. Every atom in your body, the iron in your blood, the calcium in your bones, the carbon that every biological process you have depends on, was forged inside a star that lived and died before our solar system existed. Massive stars burn through their fuel, collapse, and explode, scattering heavy elements across space. New stars form from that enriched cloud. New planets condense around those stars. And on at least one of them, over billions of years, those scattered atoms arrange themselves into something that can sit here and think about where they came from. That's not a poetic way of describing what happened. That is literally what happened. You are the universe examining itself, not metaphorically. The atoms that make you up have existed for nearly 14 billion years. For almost all of that time, they were part of stars, gas clouds, the empty void between galaxies. And for this brief window, they're part of something aware enough to look back and ask questions. Most of the universe is empty. Most of the matter in it is dark and invisible. Most of the energy in it is something we can't describe. 95% of everything that exists is beyond our ability to detect. And in a small, specific corner of the remaining 5% on a planet that would be invisible under a microscope if you zoomed out far enough, something woke up and started trying to understand all of it. We haven't figured it out. We probably never will completely. But in the few hundred years since we developed the scientific method, we've worked out the age of the universe, the size of the observable cosmos, the existence of dark matter, the nature of black holes, the expansion of space. We've detected gravitational waves, ripples in space-time from black holes colliding billions of light years away, with instruments sensitive enough to measure a change smaller than a proton's width. That's what awareness does with a few hundred years. The universe is 13.8 billion years old. We've been doing modern science for about 500 of them. We're just getting started. So when the scale of all this starts to feel crushing, when 2 trillion galaxies and 95% invisible matter and an accelerating expansion that's erasing the evidence starts to feel like too much, remember that you're not just a bystander to this story. You're the part of the universe that noticed it was a story. That's not small. That might be the most extraordinary thing in 93 billion light years.